the meter we all use is about 0.2 of a millimeter shorter than it was meant to be and has been since 1799. Listen for the two measurements that refuse to agree. We begin on the road south. In late June 1792, two astronomers left Paris in opposite directions. Jean-Baptiste Delambre north towards Dunkirk, Pierre Metre south towards Barcelona, 4 new brass instruments between them. The assignment sounded modest. Measure the arc between the two cities, belfry to fortress, hilltop to hilltop, so that a new unit of length could be anchored to the meridian itself. The work was expected to take about a year. It took nearly 7, and one of the two men came home carrying a number he could not explain and could not check. The definition dated from 1791. The meter would be 1/10,000,000th of the distance from the North Pole to the equator, measured along the meridian through Paris. The stretch from Dunkirk to Barcelona would be surveyed directly, and the rest computed from it. The key instrument was the repeating circle, brass, 2 small telescopes on a shared axis. Its genius was patience. It measured the same angle again, and again, and again, never resetting to 0, until the small errors of reading divided themselves away. The survey was a chain of 115 triangles, each corner solid and visible from afar. The church belfry of Saint-Éloi at Dunkirk, the cathedral of Rodez, where the two sectors met, the fortress of Montjuic above Barcelona. Angles give a chain its shape, not its size, so in 1798 Delambre spent 6 weeks laying 4 platinum measuring rods end to end along roughly 12 kilometers of straight road near Paris. A second baseline near Perpignan was measured purely as a check, and the triangles, carried south, predicted it to within 1 part in 37,000. Whatever else this story holds, the triangles were sound. The obstacles were rarely scientific. Delambre was stopped repeatedly, once because his travel pass bore the signature of an authority that no longer existed, once because officials found the repeating circles in their cases suspicious. And at the end of 1793, his authorization was withdrawn altogether, boxing the instruments for about 18 months. Metre's share was harsher. In 1793, helping a friend at a pumping station outside Barcelona, he was struck by a lever that broke ribs and a collarbone. Then the border between France and Spain closed behind him, cutting him off from his stations. From the fortress of Montjuic, he had already fixed the latitude of the arc's southern end. The following winter he measured the same latitude again, from the terrace of his inn, about a mile from the fortress, tied to it by a short chain of small triangles. Same city, same man, same instruments. The two latitudes should have differed by exactly the known north to south step between the two stations. They did not. The disagreement came to about 3 seconds of arc, a second being 1/3600th of a degree. By March 1794, he knew it was there, and the one remedy, climbing back to the fortress to observe again, was closed to him. The site was no longer accessible. Worse, he had already posted the fortress results to Paris before finding the problem. The number he doubted was in the mail, traveling towards permanence. What he did next is a matter of record. He did not report the disagreement ever. He kept it to himself for the rest of his life. 3 objects deserve a closer look. A repeating circle, a brass instrument with 2 small telescopes on one shared axis, built to measure a single angle over and over until the errors average away. A measuring rod, a straight bar of fixed length, laid on the ground end to measure distance directly. And a belfry, the bell tower of a church, visible for miles across flat country, exactly what made it the perfect corner of a triangle. A repeating circle, a measuring rod, a belfry. The two chains met in the autumn of 1798, and by late November both men were back in Paris with their records. The final value was fixed not by the men who had measured it, but by an international commission. 12 representatives from France, joined by delegates from the Dutch Republic, the Italian states, Spain, Denmark, and Switzerland, who worked through the notebooks and settled the meter, in the spring of 1799, at 443.296 leans. In June, a platinum bar of that length was deposited in the National Archives. A provisional meter had already been in legal use for years. 7 years of hilltops had moved it by about 1/3 of a millimeter. And a committee can only read what is in the notebooks. Metre might have let it rest. Instead, in 1803, he left Paris to extend the meridian south to the Balearic Islands, insisting on the work himself, although another astronomer had first been named. One effect of the extension, had it succeeded, is pure geometry. His Barcelona latitude would have become unnecessary. In January 1804, his mainland station proved invisible from Ibiza. He redesigned the chain and pushed down the coast. That September, he fell ill with a fever and died on the Spanish Mediterranean coast. He never saw Paris again. Metre's papers came home to D'Alembert. One historian who has examined them closely reports a field record kept in pencil on loose sheets, and argues that some in-values had been adjusted while the fortress values stood untouched. It is not clear how much weight that reading can bear. By the same account, D'Alembert then retraced the pencil in ink, pasted the sheets into a bound volume, and deposited the private letters under seal. And in the expedition's published record, he printed the fortress data and the in-data side by side, 2 columns that disagree, over the name of a man who could no longer be asked. 3 more objects for the second half. A plumb line, a string with a small pointed weight at its end. Hang it, let it settle, and it shows the local vertical, the direction of straight down. A fortress, a stronghold with thick stone walls built on high ground to guard a city. The one above Barcelona held the southern end of the arc. And a platinum bar, a flat length of dense, silver-white metal that neither rusts nor wears for over a century, the meter itself. A plumb line, a fortress, a platinum bar. So what had happened on that terrace? Modern geodesy answers. Nothing had. A plumb line does not truly point at the center of the Earth. Local mass, a hill, a coastline, dense rock underground, pulls the weight sideways by a few seconds of arc, so straight down at the fortress and straight down at the inn were genuinely different directions. Measured against its own vertical, each latitude was right. Deflections of that size are ordinary in hilly country, and nothing available in the 1790s could have measured the tilt at those 2 stations. The error Metre carried was not an error at all. And the 0.2 of a millimeter? A separate account, it cannot be charged to the terrace. A 2019 study in the Journal of Geodesy reran the arithmetic. The meter in use is shorter than its intended 10-millionth by roughly that much, and about 95% of the shortfall comes from neglected gravity, the very deflections nobody could then measure. The surveying itself contributed less than 2%. The silence changed nothing. A 2007 essay that went back over the affair reaches the same verdict from the other side. Metre died fearing he had possibly damaged the foundation of the metric system, and he had not. One step remains. In 1889, an international conference sanctioned a new prototype meter of platinum iridium, its length made equal to the bar of 1799, the bar, not the Earth. From that moment, the meter stopped being a piece of the Earth and became a piece of metal. In 1960, the bar gave way to a wavelength of light. In 1983, to the distance light travels in a set fraction of a second, and the 1983 resolution states that the change introduces no appreciable discontinuity into the unit of length. Each definition was chosen to match the length already in use, and the shortfall traveled inside it. Nobody went back to the Earth. After 1889, the Earth was no longer the thing being asked. Imagine the ending Metre wanted. He survives the fever, climbs Montjuic, observes a flawless latitude, and writes to Paris. Paris compares his number against what? Against the bar in the archives. In practice, the bar had been the reference since 1799. In 1889, the definition caught up when the new prototype was made equal to the bar, not to the Earth. A bar cannot disagree with itself. The latitude he doubted had already gone into the value, and the value had become the bar. A definition is not the kind of thing a measurement can contradict. No ledger had a column where his correction could go. The same shortfall, stated the other way round, is about 2 kilometers on the Earth's own quadrant. 4 quick checks. 1. The meter was defined as which fraction of which distance. 2. The 2 Barcelona latitudes disagreed by roughly what angle. 3. Who settled the final value in 1799, the surveyors or someone else? 4. The 1889 prototype was made equal to what, the Earth or the bar? If the last answer feels self-evident now, this story has done its work. That was the meter, measured by 2 men, settled by a committee, preserved through 3 redefinitions, and short by about 0.2 of a millimeter. A shortfall each later definition chose to carry forward. The 6 objects wait in the subtitles: a repeating circle, a measuring rod, a belfry, a plumb line, a fortress, a platinum bar. A second listen is where the architecture shows. All images are AI-generated reconstructions, and the narration is synthetic. Next, another piece of history that reads like an invention. Until then.